In order for an operating system to be able to work with memory, the memory has to be detected in the first place. Depending on what kind of equipment we have, memory will either be detected by a parallel presence detect, or PPD, which uses resistors to communicate the type of memory present, or a serial presence detect, SPD, which stores the information about the memory type in an EEPROM, or electronically programmable read-only memory. But different operating systems view memory very differently. For example, the earlier operating systems like DOS and DOS with Windows 2X and 3X operated in what was called real mode. In real mode, memory has direct access to hardware, which meant that there was no real protection of the memory against the devices in the computer. The main disadvantage of that was that we couldn't multitask. DOS Windows 3X ran in both real mode as well as some 16-bit applications that could actually run in a virtual mode, which allowed us to multitask. Windows 9X, Windows NT, and Windows 2000 can run in a protected mode, which allows the operating system to be able to multitask because memory is protected and hidden from the devices. We have memory managers then that manage devices like hardware and also software memory, so that many different things can be happening on the computer at one time. This is one of the big advancements in memory management in the computer. There's a difference between memory itself and a memory address. Physical memory is stored on a chip. The physical memory is actually stored in the memory chip itself. The memory address is a number that the CPU assigns to the physical memory, and both ROM and RAM are assigned memory addresses in order for the CPU to be able to access them. So next we'll take a look at how each of the operating systems manages memory.